Welcome back to Cosmic Galaxy. In this video, we're discussing Hubble detects protective shield defending a pair of dwarf galaxies. Make sure to like the video, subscribe to the channel, and hit the bell icon. The Milky Way's largest satellite galaxies, the large and small Magellanic Clouds, have been on a perilous journey for billions of years. They have begun to unravel as they orbit one another as they are drawn in towards our home galaxy, leaving behind trails of gaseous debris. Despite this, astronomers are perplexed as to how these dwarf galaxies remain intact, with ongoing rigorous star formation. Many people were puzzled as to how these streams of material could exist. If this gas was removed from these galaxies, how are they still forming stars? A team of astronomers finally found the answer, thanks to the data collected from NASA's Hubble Space Telescope and a retired satellite called the Far Ultraviolet Spectroscopic Explorer, FUSE. The Magellanic System is surrounded by a corona, a protective shield of hot, supercharged gas. This cocoons the two galaxies, preventing the Milky Way from siphoning off their gas supplies and allowing them to continue forming new stars. This discovery, which was recently published in Nature, addresses a previously unknown aspect of galaxy evolution. Galaxies surround themselves in gaseous cocoons that serve as defensive shields against other galaxies. Astronomers predicted the existence of the corona several years ago. They discovered that including a corona in simulations of Magellanic Clouds falling onto the Milky Way allowed them to explain the mass of extracted gas for the first time. They knew that the large Magellanic Cloud should be massive enough to have a corona. However, despite stretching more than 100,000 light-years from the Magellanic Clouds and covering a large portion of the southern sky, the corona is effectively invisible. It took 30 years of searching through archived data for suitable measurements to map it. There are many computer simulation predictions about what they should look like and how they should interact over billions of years. But we can't really test most of them, because dwarf galaxies are typically too difficult to detect. Because they're so close to us, the Magellanic Clouds are an excellent place to study how dwarf galaxies interact and evolve. To find direct evidence of the Magellanic corona, the researchers combed through Hubble and FUSE archives for ultraviolet observations of quasars billions of light-years away. Quasars are galaxies' extremely bright cores that contain massive active black holes. Although the corona would be too dim to see on its own, the team reasoned that it should be visible as a fog obscuring and absorbing distinct patterns of bright light from quasars in the background. In the past, Hubble observations of quasars were used to map the corona surrounding the Andromeda Galaxy. The team was able to detect and characterize the material surrounding the large Magellanic Cloud and confirm the existence of the corona by analyzing patterns in ultraviolet light from 28 quasars. As expected, the quasar spectra bear the distinct signatures of carbon, oxygen, and silicon, which comprise the halo of hot plasma that surrounds the galaxy. The team discovered that the amount of gas decreases with distance from the center of the large Magellanic Cloud by mapping the results. It's the perfect telltale sign that this corona is real. It truly is cocooning and protecting the galaxy. Thank you for watching the video.